All right, nerds. So, like I said before I started the recording, we are going to go ahead and tackle all of Unit 636 in one day because we're going to trim the fat off of this packet and we're going to do the things that we know how to do, and we're just going to breeze by the bloat, okay? So what have we not covered so far? The only thing we haven't really covered is how to graph things that have been shifted horizontally. And in trigonometry, these are known as phase shifts. Now, just so you know, in these images, we were supposed to be writing down where the key points are. But no, I'm not doing any of that because I don't have that crap memorized. I'm not trying to memorize that stuff. I can barely memorize my students' names, okay? So memorize as little as possible. Instead, know the shape, amplitude, period length, midline, and lastly, where to start. And that's what the phase shift does for us. You always want to start at what makes the inside equal 0. And we have used that terminology this year already. What makes the inside equal 0, haven't we? It's how you find the vertex of a quadratic. It's how you find the inflection point of a cubic that's written in standard form. It's how you find the beginning coordinate of a square root graph. What makes the inside equal 0? So we're going to start all of our trig waves at what makes the inside equal 0. And the reason why is because the parent sine wave starts at the y-axis where x is 0. And the parent cosine wave starts at the y-axis where x equals 0. So we're trying to figure out what makes the inside equal 0. And that'll tell us where that point goes and where that point goes. What makes the inside equal 0. At least it'll tell us the x value of where it goes. And just to make sure we're all clear on this, we all know that horizontal inside opposite, right? So if you see an x plus pi, that is left pi, correct? Remember, they're not going to say left and right on the AP exam. They're going to give it a positive or a negative descriptor. So if you wanted to say left pi, you have to go horizontal translation of negative pi units. But hopefully you understand that negative pi means to the left, right? And you know that the symbols on the inside are always the opposite. Now, I do want to point out something now that we're talking about these inside transformations, and this is true for both sine and cosine, is what can you tell me about the argument of this trigonometry? What do you see? It's not distributed. Specifically, it's factored. You want to always have your arguments factored. If you don't factor the argument, it is going to be very difficult to graph. Trust me on that, it really sucks. Okay? For example, let's say we had this. Sine of (2x plus pi). Where would you start that wave? Not at negative pi. Because negative pi does not make the inside equal 0. Now, if you were going to describe these transformations to me, I know I taught you that you could say that this is pi units to the left, followed by a horizontal dilation of factor 1/2. You know, because inside opposite, right? Sad mep. But it will never be done that way on the AP exam. AP, College Board, is always going to factor these double horizontals. Always. And so they would be presented like this. The nice thing about that is it shows you exactly where to start. Start at negative pi over 2. And if you wanted to describe these transformations, you describe them from left to right, just like you would everything on the outside. So as long as it's factored on the inside, You could describe it left to right. You say horizontal dilation, factor 1/2, and a horizontal translation of negative pi over 2 units. You get to say it in the order you see it, as long as it's factored. Cool? So if the trig is presented to you and the argument is not factored, your job is to factor it. All right? All right. We already know what all of these things do, skipping over that joint and coming straight to graphing. And I'm going to have you do this the way that I do it. I'm not even going to bother reading the words up top because as far as I'm concerned, they're probably confusing. I haven't read them once. I don't need to. We're going to graph this thing. Here's how I do it. First, I identify shape. And I see a positive sine wave. A positive sine wave has that shape. Cool. Once I've decided on my shape and I draw a little sketch of it, I find my midline. My midline comes from the vertical shift. And there isn't one. There isn't one. So my midline happens to be at y equals 0. So I throw a couple dotted lines around y equals 0. That way I know that's my midline. Cool. Then I would decide my amplitude, or look at my amplitude, and I would see that my amplitude is 3. The reason why I would do that is because it would show me how far up and how far down I'm going to draw my dots. Awesome. Now I need to know where to start, and I need to know how long the period is. And it doesn't matter which one of those you do first, it's unimportant. So since the new thing today was phase shift, let's do it in the same order that we've always done it. Let's figure out how long the period length is. The period is 2 pi over b. Our b value is 3. So I know that my wave is going to take a total of 2 pi over 3 to complete. The distance from quote-unquote beginning to end is 2 pi over 3. Yes? Awesome. Lastly, where do we start? The number that makes the inside equal 0, which is pi over 6. This is at x equals pi over 6. And the midline is right there. So I can go directly to my graph now and put a dot at midline, comma, or pi over 6, comma, midline, right here. Wouldn't it be great to know where the end of that wave is? It would be, wouldn't it? Well, guess what? From here to here is 2 pi over 3. Let's make life easy. Let's say it began at 1 and I had to go 9. Where would it end? If it began at 1 and had to go 9, where would you end? 10. How'd you get that number? Oh, you added them. You took the beginning x and you add the length of the period to find where it ends. Let's do that. Oh man, elementary school math. I need a common denominator. Oh, that wave will come to an end at 5 pi over 6. In the dead middle, I'll be at that midline again. Between the first 2 dots, I go up to my maximum, and between the second 2 dots, I go down to my minimum. And there is 1 cycle of my graph. But you know what? The fun doesn't have to stop there. these graphs go on forever and ever and ever in both directions, right? So how about this? Why don't I continue the pattern? And continue the pattern in this direction. Now, here's what I want to do. I want to do that part as a dotted image, just to show you that you didn't have to. But I'd like you to now look at this image and tell me, if you had no equation, what would be a really easy model to use for this picture? A negative cosine, because it starts at a minimum. It's upside down. But if you say it's a negative cosine wave, you could start right there and have no phase shift. Wouldn't that be easier? So just because we can, I'm also going to write this equation as a negative cosine wave with no phase shift. Y equals negative, because it's upside down, amplitude is the same, cosine of, and since it starts right here at the y-axis, there's no phase shift, the number in front of x has to also stay the same because that's how transformations work. You're finished. Which one of those is easier to graph? Well, clearly it's this one. But if that was the case, then we wouldn't have had a chance to practice phase shifting. So, but yeah, these are the exact same graph. Isn't that neat? That's over and above what was necessary in this lesson. But it's part of the reason why I'm going to be able to skip teaching this across 2 days, is because I'm combining knowledge. Let's do it again. Boop. You know what? Period 2 didn't get to see it, but I realized like really, really late in the lesson that none of these questions involve a phase shift and a vertical shift until you get to the back, and that's just what's the equation. So I want to actually graph one that has both a vertical and horizontal shift. So this has the horizontal shift. Let's give it a vertical shift. There's no reason to go nuts though. How about, no, 3 is too much. I could do 2. You want to do 2? You want to do +2 or -2? -2, she said. Nope, she beat you. She said -2 too fast. So there it is. All right. Huh? Oh, because it would fall off the grid. You want to know why it was too much? Yeah, because the amplitude is 2. Yep. But there's a lot of 2's in this question now, aren't there? Whatever, who cares? It doesn't matter. Nothing changes. The first thing I would do is decide on the shape of this graph, and what I see is a positive cosine wave. And positive cosine waves look like this. They begin at a maximum. My midline, because we altered the question, is now at -2. So let's throw that on there. I am recording, right? Yeah, okay, good. Well, I mean, if I'm not, I'm not, but I am. There. Amplitude is 2. We care because that tells us how far up and how far down to go. So I know I'm going to go up to this line, and I'm going to go down to this line. I guess we could have used 3. We just would have been topping out or bottoming out on our picture, but whatever. Period length. Luckily, the argument is factored, so I don't have to do that myself. Period is 2 pi over our b value, and our b value is 1/2. What is 2 pi divided by 1/2? 4 pi. Goodness. That means from here to here is 4 pi. So I just need to know where to start. What makes the inside equal 0? -2 pi. So I know I have a maximum at x equals -2 pi. That's here. Now go 4 pi from there. I heard him, yeah. Oh, is that your back? Don't do that. You'll get old like me and your back will be broken like mine. No, I don't know. No, I inherited all kinds of bad spine problems, so more than likely you'll be fine. Anyway, negative 2 pi plus 4 pi, because we just want to know where we're ending. So we're going 4 pi away from our beginning, and it's going to end at positive 2 pi. Oh, so at positive 2 pi, I'll be back to my maximum. That is a really wide wave. Halfway between those two maximums will be my minimum. And halfway on the x-axis is halfway between 0 and 2 pi is pi. So I'll be back to my midline at pi, and back to my midline at negative pi. And we can now draw this really wide cosine wave. And again, do we enjoy phase shifting? No, honestly no. It kind of makes graphing a pain in the butt. So why don't we write an equation for this that does not involve a phase shift? Again, allow it to begin at the y-axis. What kind of image are you looking at if it begins at a minimum? A negative cosine with no phase shift. But the vertical transformations will be identical, and the horizontal dilation is identical. It's just a negative cosine wave. So we could have written it as y equals negative 2 cosine of 1/2 x, and then the minus 2 that we added. This and this are the same graph. And obviously the one that we wrote in blue is easier to graph. Starting to see patterns? That's good. That is good. It means I'm doing my job. That's what they pay me to do, you know. So this box down below is literally just to talk about transformations. Compare and contrast what happens to the, whatever. If b is bigger than 1, it's a shrink. If b is between 0 and 1, it's a stretch. But you already know that. When the argument c is okay, if you see minus a number on the inside, that's go left. If you see plus a number on the inside, that's go right. I said those backwards. Crap. If you see minus a number on the inside, that means go right. If you see plus a number on the inside, that means go left. We've been doing that for years. I don't feel like wasting our time. Proximo. Next. Do we really need to graph these two things? Good. Those are easy, all right? We got a sine wave that shifted. I mean, look how easy this is. A sine wave that shifted down one. Okay, so it's going to do this. Instead of going from here to here to here, shift everything down one. I mean, like, look how easy that was. There, I'm done. I did it, okay? Whatever, I missed it. But you get the idea. Oh, it's plus 1? Nothing. I did it backwards. I did down one for some reason. down one, right? So midline, maximum. Wait. Yeah. Midline, minimum, midline. I'm like there, it's done, okay? There's one cycle. Like, it's a joke. I don't feel like wasting our time on these easy ones. What I want to do is I want to get to the ones that are chock full of transformations, like that one. And I want to get to writing the equations of said functions. This is just so you could write down the formulas for stuff. Oh, the variable expression of the amplitude. Oh, yeah, that's going to be the absolute value of A. And the period, yeah, that's going to be 2 pi over absolute B. Man, screw all that stuff. Who has all that crap memorized? Like, you have no reason to have all that stuff memorized. You know 2 things. Everything else is a joke, right? Do I have the 5 points memorized? No. Do I know what the transformational effects are? Of course I do, because it's the same for all functions. Do I need to write that stuff again? Please no. Please. Okay? Move on with our lives. I'm sick of transformations. They're a joke. If you ever miss a transformation question ever again, I'm coming to your house and inflicting pain. Okay? Okay. Okay? Now, there's a phase shift, no vertical shift. You want to stick a vertical shift on there? Sure? Okay. What do you want to say? Plus or minus? She said 1.5. Let's do plus 1.5. Why? Because she doesn't like you guys. Oh, we can't do 1.5 because the amplitude is 2, and my graph only goes up to 3. So I could do plus 1/2 if you want. -1. Sorry, you've been overruled. They said -1. We could do -1/2, but I'm not going to. Shape. Positive cosine. Yeah, it's -1. See, I wrote a -1 there. Midline. X equals -1. Amplitude is 2. So up 2 from 1, -1, excuse me, down 2 from 1. It barely fits, but there it is. So that's up 2 and down 2. 1/2 would have been a better shift because it would have fit better on the picture, but I know, no, I knew. They didn't, but there it is. Oh, did you? Okay. Period length. Well, there's a convenient box for amplitude, period, and phase shift here. So period length, 2 pi over 2. A period length of pi. Great. Oh, we already knew that the amplitude was 2. We already did that. Phase shift just tells you where to start. Where are we going to start? -3 pi over 2. Why is it called a phase shift? It's a physics thing. It's a physics thing. Alrighty, so I know I'm at a maximum at -3 pi over 2. That's right here. I need to know where this thing ends. So -3 pi over 2 plus pi. That's where it's going to end. -3 pi over 2 plus pi. But I need a common denominator. So it looks like it's going to end at -pi over 2. Or you could have said -1.5 plus 1, which is -1/2, if that helps. Whatever. Okay. Yeah, we're going to come to an end there. All right. Halfway between those 2 points is going to be my minimum, though, right? How many points is that? 1, 2, 3, 4. So right here, I'm going to have a minimum at -pi, and it's way down here. And halfway between them, I'm on the midline, like that. And if you would like to continue, you can. Oh, yeah. There was a way to write this without a phase shift. You see it? I could have started it right here and called it another negative cosine wave if I wanted to, because it would have began at a minimum. So no phase shift if I start it right there. If I start it right there, it's y equals, it's upside down cosine if it starts right there though, so negative. Pesky old phase shifting for no reason. Mark, you look confused. Everything okay? Everything good? What are you guys joking about? Oh, no. All right. This is just a transformation question and then sketch the graph. We know transformations, don't we? Reflective x-axis, vertical dilation factor 2, horizontal dilation factor 1/3, horizontal shift of 2 pi units. I mean, I don't want to graph it. It's too easy. No, I want to move. What do you mean, how would you graph it? You'd start it positive 2 pi, right? And instead of going forward a period length, you'd come backwards a period length. They just didn't give you space. All right, well, let's at least address it, okay? We could see that it wants us to start at 2 pi, right? And normally what we've been doing is we've been adding our period length to that to go to the right. But you know that the period, the whole point of a periodic function is that it's going to repeat forever in both directions, right? So not only could I add to go to the right, I could subtract to go to the left. So let's figure out our period length. Let's just ignore these lines. Let's pretend they're not there. The period is 2 pi over 3, right? And you're going to start at 2 pi. Let's see. Our midline is at the x-axis, and our amplitude is 2. And it is a sine wave. It's a negative sine wave, though, right? Here's what a negative sine wave would have looked like. Comfortable with that? Great. We know that we start at x equals 2 pi. So at x equals 2 pi, I'm on my midline. I'm right here. Or I'm right here. You see, it didn't matter. It doesn't matter, does it? I could either say that this was 2 pi, or I could say that this was 2 pi. Who cares? It doesn't matter. Because if I wanted to draw it again, I could. So if it was me, I would go, all right, fine, I'm here. And now let me go left 2 pi over 3. And I'll connect my dots that way. I'll just go left. So I would say 2 pi over 3 minus, 2 pi minus period length, 2 pi over 3. You need a common denominator, though. Just like that. So instead of going to the right, I went left. Jack, you okay? Okay. All right. This one's really easy because there's no phase shift. So I don't really understand the point of this. It just says more graphing. So since there's no phase shift, and we've already done ones that are even more challenging than that, we'll skip it. I don't feel like wasting our time on stuff that we've done plenty of times and I know that you're above by now. Let's write a sine function that has all of these properties. I'm going to be real with you. The hardest part about it is this part. And even that's not hard. That's just the most challenging part. It says the period length, which is 2 pi over b, is 2 pi over 3. So what does b have to equal? Yeah, b has to be 3. It's time for our equation. Y equals an amplitude of 3. It says it's a sine function. The number that sits in front of x is a 3. And there's a phase shift of pi over 3 to the right. So what goes inside the parentheses? X minus pi over 3. And it says there's no vertical shift. It's done. That's it. That's it. It's like just writing the equation. I hope you guys are seeing how easy this is. Once again, I think that's the most challenging part. 2 pi over b would get us a 4 pi. So what would I have to divide by in order to double? 1/2. In case you weren't sure how to do that, you could have done it like this and set it up as a cross multiplication, and then divided both sides by 4 pi. And you would have gotten 2 pi over 4 pi, which reduces to 1/2 if you needed to do that. It's not a big deal. Alrighty, we get y equals amplitude of 5. It says it's a cosine. We know there's a 1/2 in front. There's a shift down 2 units, and it says pi over 4 left. So x, if I'm going left, what do I see? Plus pi over 4. It's a chair that's squeaking back there. You guys see how easy this is? Graphing trig is so frigging easy. At least as long as the phase shift and the period length play nice with one another. When they don't play nice with one another, that's where things get a little crappy. But I have yet to see that happen. So, woohoo! That should make you happy. Ecstatic. Ooh, good word, good word. Alrighty. So this says write a sinusoid. That means use sine or cosine. Nobody cares. Just pick one. When in doubt, I would say go with sine. But here's why. We were told to write a sinusoid that goes through the point 2, 0. Wouldn't it be easiest if it just started at 2, 0? Wouldn't that be easy? And then just was like, okay, there we go. There, it'll do that. You were told what the amplitude is. Again, the hardest part then would be what's going to get me this period length. So that would be the hardest part again, if you set it up like that. So 2 pi over b, the period length, is pi. So what is b going to have to equal? Yeah, b is 2. And I drew it as a sine wave. So y equals 2.5, because it says 2.5. Sine, because that's what I freaking drew. We know there's a 2 in front. We have it being centered around the x-axis, so no vertical shift. And I've got it starting at x equals positive 2. So what do I see inside these parentheses? X minus 2. See how easy this can be? It's awesome. It just flows. And I don't know if you've noticed how often I'm drawing pictures of waves. I always draw the pictures of my waves before I write my equations. Unless I already have a picture of a wave. Stop flicking things around my room. What's wrong with you? God. Animals. And we don't have time to do both. We only have time to do one of them, so which one do you want to do? Nah, I want to do part B. Let's do B. Let's do B. First of all, based on its shape, what would be the easiest model to use? Yeah, negative cosine would be the easiest. And what can we see from it? What's its period length? You should be able to just see that. Period length is pi. Midline would be, I'd say, the next thing you want to track down. Y equals, what's halfway? Is it negative 3? 1, 2, 3, 1, 2, 3, nope. Is it negative 2? Yeah, because look, from negative 6 to positive 2 is a distance of 8. So halfway between there's a distance of 4. So yeah, it's at negative 2. Oh, once again, from negative 6 to 2 was 8, and half of that was 4. Oh, the amplitude is 4. All right, let's figure out our b value. 2 pi over b equals the period length of pi. So what does b have to equal? Not pi, 2. And we said it's a negative cosine based on its shape. So y equals negative amplitude cosine of 2. And since it starts right here at the y-axis, no phase shift. But just because I think it's really good practice, let's also write this as a sine wave, a positive sine wave. I want to do a positive sine wave. Let's start it. Where would a positive sine wave start? What x value? You have them backwards, but yes. Pi over 4 comma negative 2. That would start my positive sine wave. Same amplitude, but positive. Sine of, same number in front of x. Same, oops, I forgot to write the midline. So sorry about that. Same midline. And if it's starting at pi over 4, what do I see inside these parentheses? X minus pi over 4, because it's shifted to the right. You see, it's so good that you have this ability. Now we're not done, because we're supposed to do the maximums, minimums, and inflection points. How about we just say it? Where do I always find inflection points on sine and cosine waves? On the midline. You will always find a point of inflection every time you're on the midline. Okay? I'd say that's done. Do you see how good you are at graphing trig and at writing trig equations? Do you see? Freaking nerds.